Okay, so welcome back. Another stream from Micro Soldering Solutions, and today we've got a Nintendo Switch, and it is coming not charging. So let's plug in the charge port and see if we get anything on screen. We should get a battery indicator up here. I can see on my USB test meter that we are getting 94 milliamps. That is not enough to charge. So let's get you round and let's see what voltage we're getting there. So we'll just use this as a ground plane, and right in front of the charge port we've got a test point here, and it should be 15 volts, and we have 5 volts. So 5 volts is basically what's being produced by the power supply, and we need that to be 15. So that does tell us that something is indeed wrong, but it does also tell us the charging port is good, because it's allowing voltage through. If that wasn't working, that would be 0 volts. So we've got something else going on there. We'll disconnect the battery and pull out the charge port. And this up here, we have the charging IC. And yeah, it's responsible for charging. And we shall get a look at that under the microscope. And we'll put the test meter onto continuity mode so we can see if we do indeed have a short up here. So there we are, the M92T36. That's the charging IC. There is also another common failure, which is the P13 USB, and we can test that on this capacitor here. So the bottom leg, we should have a continuity to ground, which we do. But if we've got it on the top, that means the P13 USB chip is bad. And we don't. So we can deduce from that the P13 USB is good and we've got no issues. No issues there, another cap, no issues there, no issues here. Oh. And we've got a short up here and a short up here. So this chip is probably bad. P13 USB is okay, charge port is okay, and this is what we're going to need to change. So let's switch on to the battery again and see. I have put some power into this. It was completely dead, but it will also show us on screen another error that we get is 2162-0002, which is a power error. Let that switch on and we'll see, and there we are, error code 2162-0002. Don't know if you can see that there. It doesn't want to focus. But anyway, it says it just here, and that's also a common indicator that the charging IC has failed. So I'm going to have to stop it here, call the customer and see what they want to do, and if they decide to go ahead and have that fixed, I will get the stream started again, and we'll get it fixed. I'll show you how, and hopefully we'll have a working machine again. So if you have this, any charging issues at all, Nintendo Switch, give me a call, contact me on Facebook, and we can get that up and running for you again. So for just now, bye bye, and yeah, we'll see what she wants to do, or he. Okay, so we're back, and we have the Nintendo Switch again that we did the strip down, and we were waiting for the customer to say yay or nay. So we got the new chip in this morning. That's it right here, and we need to replace that one. So we'll go ahead and get this one off and make this thing good again. There we are, it was jammed in a cable there. Okay, so we need a little bit of flux just to help the solder melt and flow. I'll do that. And there we go. Let's get this one off. Oh, wait a minute. That nozzle is way too big for our needs. Okay, there we go. Better. to gradually take up the temperature of the board so it doesn't get a thermal shock. We'll easily know when we're ready to go in. You'll see it in the flux, it'll start to bubble. Starting to go, and it's off. There we go. And the new one is right here. Just melt and stick down, and then we'll let this find its own place. And let's just push it down into place. There we go. And hopefully that's all made a connection. Let's just get a look. That all looks good there. Looks good there. That looks good, so I imagine this side will be hunky-dory as well. Yep, all looking good. And now we can test for shorts on that capacitors again where we had it before. So use this as a ground plane, and there we are, no beeps. And P13 USB is good. So hopefully when I put this back together we shall have us a working and fully charging Nintendo Switch. Right, that's all cleaned up. Let's get the housing. And the battery connected out the road. I will switch it back onto camera so you can see. Oh, that's turned. We need this back over here. There we are. Right. I've got the shakes today, which does not make this an easier job. So let's get you up, get you out. Come on, there we go. And you, and there we are, that's you down. So let's plug this all in again. The thing about micro soldering and using hot air is knowing how to read what the board is doing. You use too much heat, you can kill a device. You don't use enough heat, you can fry the board. You'll just heat it up and it will do nothing else. So it's not good doing that either. So it is just enough to melt solder and no more. The second you've got it hot enough, you get that air off. I use the drop method, which means that the second it's all melted, the chip will just drop. So I know that I'm not going to heat anything else up unnecessarily, which is kind of important. We really don't want to do that. And this goes in this way. Come on. There we are, you're in. And we just need to get this one in. I'll not put the heatsink on just now. Let's just see if we can get this to charge and switch on. That would be handy. Oh. Keep you out the road. Plug you in. Right. Let's plug you in and see what you want to do. And we are charging. Just what I wanted to see. And the voltage that we have is 15 volts. Lovely. And hopefully, yep, there you are. You can see that we now have the charging symbol on the switch. So that's repaired. Happy customers. I'm going to put this all back together and get it back to the customer, but that's it. I just wanted to follow up on the device as I said I would. That's just, once you've diagnosed the fault, really is very simple to repair. But anyway, that's it for just now. Anything else comes in, we'll give you a shout and we'll show you it working again, or the repair. Bye.